So thank you for that introduction. Every time I speak at another event, I always ask if there'll be lasers, but somehow no one else has managed it. Now, was asked to come and say insightful, sensible, clever things about AI and explain everything that's happening in AI and not talk too fast and only take half an hour. I'll probably manage 2 of those things, possibly 1, but I'll see what I can do. I think a good place to start in thinking where we are with AI today is this quote from Bill Gates from 18 months ago saying that in his whole career he'd seen 2 things that were revolutionary, the graphical user interface and ChatGPT, which is a pretty big statement. And then on the other side, a month ago, 2 months ago, OpenAI raising at a valuation of $160 billion. I went and looked this up and worked out that it took Microsoft about 25 years to get to a valuation of $150 billion. And OpenAI did it 12 months, 18 months after launching their product. And again, that kind of reflects just how quickly this has all happened. This is a survey of people around the world who've used or at least heard of ChatGPT. And this is kind of unprecedented speed of adoption for a new technology. Something between 1/3 and 2/3 of people have tried this or at least heard about it already. And some of that just reflects the fact that you don't have to wait for everybody to go out and buy a phone and wait for telcos to build broadband. It's just a website and it just runs on the cloud so you can go and use it. But nonetheless, it's a pretty amazing speed, growth, penetration, interest, level of excitement around this thing. On the other hand, if you ask people what they actually mean when they say they've used it, you get a slightly different picture. The answer is that most people used it once and said, well, that was very clever, and then didn't go back. And a much smaller number of people have worked out a way that they can make this part of their life every single day. You see something similar, I think, if we look at the enterprise. Every big company has got some kind of a pilot or a trial, which might just mean that the CIO is paying for a ChatGPT account. But a smaller number of companies have actually got something into deployment. And of course, this is just having one thing in deployment. It's nothing like kind of moving your entire system over to generative AI. So we've got to this point where on the one hand, everyone is very excited and interested and thinks this is important, but we haven't actually got to the point that everybody is using it or spending money on it, at least not yet. That got us this summer to a wave of people writing stories like this saying, well, wait a minute, are we quite sure we want to spend $500 billion on this thing when we don't have product market fit yet? And some of this is just kind of the normal hype cycle. For anyone who doesn't know the idea of the Gartner hype cycle, I asked ChatGPT to draw it for me. Apparently it will take time to get to the plecom of productivity. So we'll kind of see quite how this will evolve. But if we step back from that, this is probably the more relevant cycle to be thinking about, that every 10 or 15 years the tech industry goes through a platform shift. And that becomes the center of all of the innovation and investment and company creation and change in the industry. And so that was mainframes from the mid-60s to the late 70s, and the PC, and then the web, and then smartphones. And now pretty much everybody in tech thinks that generative AI is the next big platform shift. However, that's about the only thing that we really think is clear. After that, all the questions are wide open. In fact, we're still trying to work out what the questions are. And what I've tried to do in the rest of this presentation is to try and group some of the questions and work out what we might ask, if not what the answers might be, into 3 categories. Like, how far is this going to scale, which of course is like the foundational question for everything else. How are these models actually useful? What are you supposed to do with them? And then, of course, how do you actually deploy this, which for people in this room means how do you build a product and a company out of this stuff? How do you actually take it to market? And so looking at the first of these, how far will this scale? As I think we all know, or certainly everyone in this room knows, we made this stuff work by making it much bigger than anyone thought was remotely feasible. We made it much bigger with much more data and much more compute, and that got us better results. And so the question now is, we don't actually have any theory of why that works, but it does work, or it's worked so far, so will it keep working? And there's one view that says, no, it's going to scale down inevitably, like anything else. It will slow down, and so this will be just software. And then there's another view that says, no, the scaling will just carry on working. And at the extreme, that might mean that LLMs can just kind of do the whole thing. They can replace all the other software and everything else. And you can spend hours of your life watching machine learning scientists arguing about this on YouTube, and all you'll really conclude is that they don't know. It's got Kevin Scott saying, well, it's worked so far, and Sergey Brin saying, well, yeah, but just because it's worked so far, that doesn't tell us it'll keep working. We just don't know. In the last week, we've had a flurry of stories from inside some of the big labs saying maybe it's already stopped working. A lot of argument about quite what that means, and it seems a little bit premature to just assume that it's suddenly all ground to a halt. And of course, some of this is just that scaling these models has a bunch of practical difficulties. It takes time to build gigawatts more power. It takes time to get the GPUs. It's not clear how much training data is left and if we can use synthetic data or what other kinds of data we could use. And of course, there's that foundational science question. If you do make the model 10x bigger, will you get 10x better results? We just don't know. However, we're going to find out. And so these are both Google and Meta saying that the downside of not investing is bigger and letting somebody else take this over is the downside of spending a bunch of capex that ends up not being useful for a couple of years. The quote from Silicon Valley, I think, was, I don't want to live in a world where somebody else is making the world a better place faster than we are. And that's some of what's going on here, especially if, like Mark Zuckerberg, you've got a controlling stake in the company. The thing, of course, that drives that fear is that there doesn't seem to be any kind of fundamental moat. There doesn't seem to be any sort of fundamental network effect, any fundamental reason why one company will have a winner-takes-all effect. And so this is an internal memo from Google from last spring saying, well, we don't have a moat, and neither does OpenAI. Of course, it's not quite true because the moat is capital. This is the CEO of Anthropic very casually talking about $5 or $10 billion of model building. He's now started talking about $100 billion of model building, which seems a little bit 1999. And slightly more tangibly, Mark Zuckerberg here this summer said that the next version of Llama will need 10x more compute, because that's just kind of how you go out and build them. And just to put some numbers on that, this is not a semiconductor presentation, but Llama 3.1 was 16,000 NVIDIA GPUs, so about half a $1 billion worth of chips, plus the data centers on top. And the clusters that people are using today are more like 100,000 GPUs. So there's quite a lot of money and quite a lot of chips and quite a lot of infrastructure. And of course, a lot of that money is going to NVIDIA. They updated their numbers last night, so the numbers carry on going up and to the right. So this is kind of an unprecedented chart. You have to go back to like 1999 or 2000 to see charts that look like this. And in turn, most of that money is coming from the 4 big platform companies, which will spend something over $200 billion of capex this year, almost $100 billion increased capex from last year. And they all expect to spend even more in 2025. At least that's what they say at the moment. It's kind of interesting to look at what that means for Microsoft in particular. This is capex to sales for a typical telco, Verizon in the USA. And we think of telcos as being infrastructure companies. They spend about 15% of their revenue on capex every year. Microsoft will spend over 25% of its revenue on capex this year. It's gone from being a company that sold you a $1 CD for $100 in a cardboard box to a company that actually has to build infrastructure in order to sell its products. Of course, when you have these kinds of surges of money and people talking about hundreds of billions of dollars of construction, then private equity and bankers and Wall Street start to get interested. A little company called Andreessen Horowitz, you might have heard of, apparently has 20,000 GPUs in order to win AI deals. And of all of this, of course, is coming in the context of a market where we still don't really know how this is going to work. All of the science is still changing. All of the engineering is still changing. This started working 2 years ago, and that was amazing. And then what? Well, we have a huge amount of investment into creating better results, agent models, scaling, of course, that I've talked about, multimodal models. On the other hand, a huge amount of investment into trying to make this slightly less expensive, as we've applied a huge amount of kind of data center engineering to what was previously a science project. And that cost, I think, is really important here, because the last time the software industry had marginal cost was back when this was what software looked like. It was kind of before most of us were born. This is the last time that it cost you money every time the user pressed OK and waited for something to happen. And the whole consumer internet has grown up on the premise that you basically don't have marginal cost unless you're YouTube or someone. But LLMs, and at least for the moment, still kind of do. That gets you into charts like this. So this is a cost axis, horizontal axis is cost, vertical axis is quality for the sort of succession of models that have been released by OpenAI. You've got a relatively small increase in model quality, but a huge increase in model efficiency, certainly an order of magnitude, maybe more than an order of magnitude increase in how cheap these things are, depending on how you model it. And in parallel, there's an awful lot of other models now. So these are just the models from the other three big companies. I could probably double the number of points on this chart if I included everything that's been released in the last 2 years. But what's really happening amongst all the noise is we're seeing a convergence. On the one hand, everybody has got a best model, and then everybody's got a cheap model. And the thing is, you can have the model that's almost as good for about 5% of the price. So you've got a very, very steep cost curve. What we also have on this chart is Meta, who are giving the model away for free, or almost free. And there's an old saying in the tech industry that everyone in tech is giving somebody else's business model away for free. That's what Meta is trying to do with open source. They're trying to make LLMs into commodity infrastructure that's available from anybody and that's sold at marginal cost. Apple is doing something similar from the opposite direction. Apple sells high-performance edge compute, so they want to turn LLMs into commodity infrastructure that runs on your iPhone, and it becomes just another API call. And so we've had in the last 2 years a sort of model boom in which you can choose better, faster, cheaper. You can have the best model, you can have the best cheap model, you can have the best model that fits on the edge, and that's kind of a big story for the next year. And of course, there's another model that's more and better every couple of weeks. Now, if we kind of step back from this, if you're not a machine learning scientist or a data center engineer, however, I think there's a couple of fairly simple observations one can make. Here we have Michael Corleone telling us that if anything, life is simple, it's that you can kill anyone. And I think the technology industry equivalent of this is that semiconductors are a cyclical industry. And commodity technology tends to go to marginal cost, and it tends to become even more of a commodity. And meanwhile, every new technology tends to produce a bubble. And it's very easy to call a bubble. It's much more difficult to say when the bubble will pop, but it's relatively straightforward to point to the trends that we've seen in the past. Now, if we set all of that aside, then we can ask, well, okay, this is great. There's going to be lots of models, and they're going to get cheaper, but what are we going to do with them? How exactly is this useful? And to answer that question, I think it's kind of useful to go back and think about the last wave of machine learning that started now almost exactly a decade ago with image recognition. And I would go to events like this, and I would show people demos like that, and I would say, look, isn't this cool? And the big companies in the audience would say, well done. We're very happy for you. You can recognize a dog. We are a very large German reinsurance company. We don't have pictures of dogs. What are we supposed to do with this? And it took a while to work out that the right level of abstraction, the right way to understand this, was that this was pattern recognition. And once you understand that this is pattern recognition, then you can start thinking, well, what can we turn into pattern recognition? And every software company for the last decade has basically been saying, we can turn that problem deep inside this industry or that department or that corporation into pattern recognition, and this is how we get the data, and we'll build a company around that. And we all kind of understand this now. We're kind of at the same point now, I think, with generative AI, with large language models. Okay, that's a great demo, and I can kind of see why that's cool, but I'm not quite sure how I should understand this at a kind of a conceptual level. What is this? How do we think about what we could do with this? We also, of course, have to remember the things that we can't do with this. You can't use this as a database. So this is still my favorite example of hallucinations. Air Canada used an LLM to build a customer support bot. A customer asked about the return policy. The support bot gave them a return policy. It was a very good return policy. Unfortunately, it wasn't Air Canada's returns policy. And the customer had to go to court to get a refund because Air Canada said, well, you should have read the other part of our website, not that part, and the judge did not find this very impressive. And so there's a sort of challenge here in understanding what it is that these things are doing. And in thinking about how it is that you would build products around something that can automate a task but might not get it right. One answer is, well, just make the models better, which would be nice, but we don't really know if we can do that. And it's not particularly clear that a probabilistic model can produce deterministic answers anyway. That seems a little bit like Zeno's paradox. So you ask, well, on the one hand, what are use cases where there isn't a wrong answer? or use cases where the errors are easy to see. On the other hand, how do you abstract this away? How do you build product design around the fact that it might be wrong? How do you manage that, provide tooling, analytics, metrics, user experience to manage those kinds of questions? The big place, of course, that at the moment that this is interesting is asking, can you use this for general search? Can you use this to replace Google? And there's a lot of sort of unknown answers to that. What kinds of queries is this good for? What kinds of queries does it matter if it's wrong? Where does it matter if you can't tell that it's wrong? How much filtering do you need on this? We don't really know, neither does anyone at OpenAI, but Alphabet made so much money from search that it seems like it's worth trying to find out. And so if we go back to my question, like how do we work out the right level of abstraction to understand this? We can sort of say, well, it's reasoning and synthesis and summary, or it might be. We can step back and say, okay, this automates a class of things that we couldn't automate before, and we're kind of trying to work out what things we can automate. One of the ways I used to talk about the last wave of machine learning was to say that this gives you infinite interns. So you would like to listen to every call coming into the call center and tell me if the customer's angry. You don't need an expert for that. You could just use a 10-year-old, except you could never automate it. And machine learning lets you automate kind of a whole class of thing that you just kind of need a mammal brain to do. You can kind of look at generative AI and try and work it out from kind of conceptual pivot points. So you can say, what does it mean that creating certain kinds of content is going to be free? What does it mean that translation will now be more or less perfect and free? What does that do to science or pop culture or the nature of the web? You can also try and do it top down as a kind of macroeconomist, and you can say, which industries have low labor productivity? Which industries seem to be full of lots of people doing very boring work that's very repetitive, that somehow we couldn't automate before? We'll probably be able to automate all of that. And then you can kind of go across industries and kind of produce a plot like this. I think that the challenge with this kind of exercise is, imagine that you'd done this for the internet in 1995. What would you have got right, and which things would you have completely missed? Can you really kind of model the evolution of a transformative technology like that? I'm not sure that you can. And meanwhile, if you're actually sitting in a big company saying, why should I double my Microsoft spending? You get to quotes like this. Chevron's CEO employs 200,000 or 300,000 people. Microsoft is saying you should give 200,000 people a license for Copilot and double your Microsoft spend. And he's thinking, yeah, but why? What value is it exactly that we're going to get from that? What are they going to do with this? I think perhaps kind of a slightly more useful way to look at this is to try and unbundle it a little bit. This is a wonderful advertisement from the 1970s for VisiCalc, which was the first successful software spreadsheet. And so what you do with this is you type in a grid of numbers, and then you can change a number here, and all the other numbers on the screen change. And we look at this today and we think, yes. But if you were an accountant in 1978, that was your entire life. You could have spent weeks doing that, and now this software just did it for you in like 10 minutes. So the founder of this company has all these stories of accountants who would do a 1-month project in 2 or 3 days and then go and play golf for 3 weeks and then come back and say, I've finished now. So if you're an accountant and you saw this, you had to have it. But if you were a lawyer and you saw it, you would think, well, that's very clever, and maybe my accountant should see this, but I don't have that use case. That's not what I do. And I think that's the way the other 90% of people react when they see ChatGPT. They say, well, that's very clever, but I don't do that all day. So if we ask who has that use case today for generative AI, particularly for ChatGPT, there's some things that very clearly do have that use case. So software development works right now, and companies are already talking about 20 and 30% efficiency gains. People in marketing are saying something very similar. They don't really have wrong answers, and if there are wrong answers, they're kind of easy to see. A lot of people in customer support are very interested in this, although, as I said earlier, you kind of have to be careful about that. And then you've kind of got early adopters across every industry who are starting to play with it and try and work out what they would do with it. And that gets you to some numbers like this. How many employed people in the USA are using generative AI, and how much are they using it? And you can see in some fields, something like 20% of people are willing at least to claim that they're using generative AI. Now, of course, you could suggest here which fields are people most likely to bullshit, and is anyone in management going to admit that they're not using ChatGPT yet? Maybe not. On the other hand, over in something like law, it kind of matters if this thing says something that isn't quite right. So you have this kind of widespread adoption. For everybody else, I think, though, you've got this problem that we have a technology and we're asking the user to work out what to do with it, which gets us to this great quote from Steve Jobs. That's kind of not normally the way we go about deploying technology. We normally start from the other end. We start from working out what the customer experience should be and work back to the technology, when right now we're kind of trying to do the opposite. And so that gets me to my third section. How is it that we deploy this? How do we build products with this? How do we build companies with this? And as we ask that question, there's a bunch of very common patterns for every technology. How do we always do this? Well, first of all, you try and absorb it. The incumbents try and make it a feature. We bolt it into the existing business. We automate the things we already do. Then, over time, you start changing the way you do your business. You start creating new products. You start creating new ideas and maybe unbundling the incumbents. You unbundle something out of SAP or Google or Oracle. And then every now and then someone will come along and actually fundamentally redefine what the market is. Airbnb comes along and changes what you mean when you say a hotel. That's the bit that's kind of hard to predict. And so you can kind of ask as you look at this, are you asking an Accenture kind of a question or a Bain, BCG, McKinsey kind of a question? Is this a question for your CIO or is this a question for the CEO? Is this top-line innovation or bottom-line innovation? And the answer is it might be all of those, depending on which part of the company you're talking to, which part of the industry, which kind of consumer, which kind of problem. It might be all of those at once. The first answer, of course, is that you call up McKinsey, you call up Accenture and you give them an RFP. And so Accenture reported that they're now doing $1 billion a quarter of generative AI, although I'm not quite sure what they're calling generative AI, but whatever Accenture calls generative AI, they're doing $1 billion a quarter in that. And that gets you to some very kind of boring traditional enterprise procurement questions. Do you buy versus build? Do you use the big companies or small companies? Will Google own the whole thing? And the most important question of all, what does this do to our EPS? And those kinds of questions get you charts like this. For most people in this room, cloud is old and boring and done, and that's like what your parents worked on and it's finished. But in actual big companies, a cloud is still only sort of a quarter to a third of enterprise workflows. Even though CIOs, of course, always desperately hope that they'll be able to get the budget to double that in 3 years' time, but somehow never manage to do so. And we see something very similar here for what CIOs think is going to happen to generative AI. Maybe a quarter of them think they'll have something deployed by the end of this year. Another quarter of them think probably not until 2026 or later. So it takes time to deploy this stuff. It takes time to work out what you do with it. It takes time to build it into products. When you do that, you have kind of a tidal wave of new products. So the SaaS, which as I said is still only sort of a quarter of enterprise workflows, now means that the typical big company department has got 50 to 75 applications. And the typical big company overall has 400 to 500 SaaS applications. What all of those are doing is unbundling Excel or email or SAP or Salesforce or Google and turning that into some workflow that they've managed to automate. And we saw that with machine learning over the last 10 years. We'll see it again with LLMs as people use this to unbundle some task and automate it again. Hence the classic quote from Jim Barksdale, there's two ways you can make money, bundling and unbundling, and that's what startups do. Now, the counter-argument to all of this, what you might call the AI maximalist view, is to say, yes, but what about the scaling? So let's come back to this slide. Is this stuff going to keep scaling or not? If the scaling keeps working, then what happens? Well, then it might be that the LLMs just become the whole thing. And the LLM sits on top and runs everything else and makes everything else an API. And you might have radically more stuff being done with software, but without needing radically more apps or more companies or more products. You could just ask ChatGPT to do it for you. On the other hand, if what we've got now is kind of conceptually where we're going to be, then the LLMs are probably just going to be another API call. You will build software, you will use an LLM to do a thing for it, and that will be an API call just like storage or calculation or indeed image recognition. And that gets me to another Steve Jobs quote, which is it's not actually the customer's job to know what they want. It's not the customer's job to work out what to do with this. And there's a kind of a challenge, I think, in giving everybody at Chevron an LLM today, which is that the classic way that we work out what to do with technology is that startups pick up the technology and invent use cases and invent problems and invent ways that you could do things that you could do with this. But when you give everybody an LLM, you're forcing the users to invent the use cases and work out what they're supposed to do with it, which isn't really how innovation works. Now, I think if you look at charts like this is startups going through Y Combinator. This is a bet on there being thousands more companies and thousands more use cases, and on LLMs being another API call. Because if ChatGPT could do the whole thing, then you wouldn't need all these AI companies. Now, the extreme case here, of course, is that this just becomes a feature. And so on the right here, we have a screenshot of Apple's new AI-powered writing tools. I look at this and I think this is spell check, or this will become spell check. Rewrite this, proofread it, summarize it, check the spelling, check the grammar. These just become features that disappear into the background. And there's a progression here, I think, with AI, that to begin with, it's AI and it's amazing and sexy and exciting and cool. And then a little bit later, it's just smart. So it's smart suggest, smart format, smart recommend, smart layout, smart summarize. And then a little bit later, it's auto, so it's autocorrect or auto format. And then it becomes just software. It's just what's always been there. And so I think if we try and imagine some models for what products we do with this stuff might look like, again, I'd suggest kind of 3 categories. The stuff that will be new features, it will rewrite my email, it will summarize the reviews, it will suggest something, it will make something. There will be completely new tools and completely new capabilities and features, just as we always have had for the last 50 years. And then there's this kind of maximalist view that says I can just go to ChatGPT 7 and say, yeah, so I'm moving to Singapore, can you buy me a house and sort out the visa? And it will just do it. And that's not quite science fiction, but it's still definitely kind of an outlying view. Hence, if I kind of pull all of these threads together, I've spent a lot of the last 18 months talking to big companies and groups of people about AI and got a lot of questions. And it seems to me that all questions about generative AI have one of 2 answers. The answer is either it will work just like every other platform shift, or we don't know. So, should we buy from Google? Will Google go control the whole thing? Will there be any startups? Do we need our own national strategy for this? Do we need our own national strategy for AI? To me, that's like saying, do we need our own national strategy for SaaS? Do we need our own national strategy for SQL? That doesn't seem like the right way of understanding it. This is just another platform shift. The other set of questions are, okay, how much will the model scale? What happens to error rates? Is there enough data? How much energy will this need? Will we be able to have models that can train themselves continuously? So all sorts of kind of science questions as to how good this will get, where the answer is, I don't know, but neither does anybody else. No one knows, and we'll just have to kind of wait and find out in a couple of years. Meanwhile, it is kind of worth pointing out that all the stuff that we were excited about 2 years ago before ChatGPT 3.5 launched is kind of still there and still happening. And one of the ways I tend to think about this is that the tech industry is always very excited by things that are going to happen in 2025 or 2030. So 2 or 3 years ago, that would have been crypto. Obviously, no one here believed in crypto, but there were other people who thought that crypto was going to be a big thing. And it was going to be metaverse, and it was going to be AR and VR. Now, of course, it's all generative AI. Meanwhile, most of the actual software industry is deploying ideas from 2010 and 2015. SaaS, cloud, automation, workflows, business process management, collaboration, Google Docs but for video, Google Docs but for this. We found this problem deep inside the HR departments in the finance industry, and we built a SaaS company to solve it, and that will be $1 billion company. That's what most actual software companies are doing. And then the rest of the economy is being overturned by ideas from 2000, like kind of wild, crazy, bizarre ideas like maybe people will watch TV on the internet, which was definitely a crazy idea in 2000 and took 25 years to happen. And so if we think about what some of those things look like, firstly, and I did this chart last year, Metaverse actually is still doing Metaverse. Meta is still doing Metaverse. Invested $17.5 billion in the last 12 months in the Reality Labs division, which is massively more than Apple spent to get the iPhone out of the door. But meanwhile, there's a bunch of other stuff that's still going on. So this is kind of the most boring chart in the tech industry. Like, it went up 1 percentage point every year for 20 years, except for that little bit in the middle. But that's just now 20-25% of retail. It's trillions of dollars of value. And when that happens, all sorts of other things change. So Shein is now almost certainly the world's largest apparel retailer, aggregating Chinese manufacturers and shipping directly to the West. $45 billion of GMV last year. Their IPO prospectus will come out any day now, and then we'll find out where they are today. Shopify did over $150 billion of GMV last year, which makes it about a third of the size of Amazon, and that's enabling tens of thousands of small businesses to produce a best-in-class e-commerce experience. Amazon itself now makes more money from advertising than almost anything else, certainly more money than it makes from retail. It did over $50 billion selling advertising on the Amazon.com site in the last 12 months. The software industry is eating television. YouTube did $50 billion of advertising and subscription revenue in the last 12 months, which is bigger than any global media company except Disney. And if you were to subtract sport from this, it would probably be bigger than Disney as well. Software is also eating cars. I'm old enough to remember when we were excited about autonomous cars. Waymo is actually doing 300,000 robo-taxi trips a month here. So Waymo has actually kind of got something working, maybe, which is more than some other companies we could mention are talking about. The interesting question, though, as we look at cars, is that the car industry is going to go to electric, and that's going to be powered by software, but who is it that's going to do that? Is that going to be software companies, or is it going to be a whole new generation of car companies? How is this going to work? And I think there's a kind of a generalized question here, which is that technology changes all the parameters. Technology changes all your assumptions about how these industries work. But then all the questions for that industry are no longer tech questions. All the questions for TV now are TV industry questions. All the questions for Shein are apparel questions. Is the Chinese car industry going to do what the Japanese car industry did in the 80s? This is a car industry question. This is not a software industry question. And so coming back to a quote I used earlier, this is Larry Tesler, as a pioneer of computer science and of AI, said, "Intelligence is whatever machines haven't done yet. AI is whatever doesn't work yet." And he's partly kind of making a philosophical point here that we always redefine intelligence as anything that machines do, because if machines can do it, it can't be intelligent. But what he was also saying here is that as soon as something works, people say, well, that's not AI, that's just software. In the 1970s, databases were AI. Now they're just software. 10 years ago, image recognition was AI. I don't think image recognition is AI anymore. I think image recognition is now just software. The same with voice recognition, the same with pattern recognition. And so by default, the process we're going to go through in the next couple of years is that large language models, again, will just be software. They won't be intelligence. They'll just be something that computers do. And so I think you could kind of propose a more general version of this thesis, that technology, indeed, is whatever machines haven't done yet. And so I'll finish with one final chart, which I will use a great deal because it took me hours to type this data in, and I couldn't get ChatGPT to do it for me. This is the number of people employed in the USA as elevator attendants. To begin with, there are more elevators, so you need more elevator attendants. Then the elevators get automated, and you don't need that. And so I'll ask you a question. When is the last time you used an automatic elevator? When's the last time you got into an elevator and pressed a button and said, I'm using an AI elevator today? In fact, an electronic automatic elevator, or is it just an elevator and that's just the way the world's always been? That's probably how all of this is going to evolve as well. And with that, I will say thank you.